At 2 in the morning, in an unmarked building on the edge of a small town in Virginia, 10,000 machines are working at once, and not a single human being is watching them do it. There are no windows. There is no sign, just a low, constant hum that never stops. 24 hours a day, 7 days a week. Because if it stops for even a few seconds, someone somewhere loses access to their bank account, their email, their entire digital life. This is a data center, and it is quietly one of the most profitable pieces of real estate on the planet. Every time you stream a show, back up a photo, or ask an AI a question, you are renting a few square inches of a building like this one, and you probably have no idea who owns it or how much money they are making from you. The person who owns that building did not build it because they loved computers. They built it because they understood something most people never stop to think about. In the modern economy, data is not just information, it is inventory, and inventory needs a warehouse. Every company on Earth is now in the business of collecting, storing, and processing information, but almost none of them want to own the physical building where that happens. It's expensive, it's technical, and it's not their core business, so they rent the space instead. The same way a retailer rents a shelf in someone else's store. The data center owner is the landlord of the internet, and like any landlord, their entire business model depends on one simple idea. Get someone else to fill your space with something valuable and charge them rent for as long as they need it there. This is where the psychology of the business becomes interesting. Once a company moves its servers into a data center, moving them out is a nightmare. It means downtime, it means risk, it means renegotiating contracts with a dozen vendors. It means the very real possibility that something breaks during the transition and the CEO gets a call at midnight. So companies stay. They stay for years, sometimes decades, even as prices creep upward, because the psychological and operational cost of leaving feels far greater than the cost of staying. This is called switching cost, and it is the quiet engine behind almost every data center's profitability. The owner isn't just selling square footage. They're selling inertia. They're selling the fact that once you're in, you're not getting out easily, and that gives them pricing power that a normal landlord could only dream of. Let's talk about what it actually costs to build one of these buildings, because the numbers are almost hard to believe if you've never seen them before. A mid-sized data center, nothing extravagant, might run somewhere between $100 million and $300 million to construct. That number covers the building shell, but the real money goes into what's inside it. Redundant power systems, because losing electricity for even a moment is unacceptable. Industrial cooling systems, because thousands of servers running at full capacity generate an enormous amount of heat, and heat is the enemy of every computer chip ever made. Fire suppression systems that use inert gas instead of water, because water and server racks do not mix. Physical security that rivals a bank vault, with biometric access, man traps, and armed guards in some facilities. And then there's the land itself, which increasingly needs to be near cheap, reliable power, and ideally, a cooler climate, because cooling costs can eat a shocking percentage of the operating budget. Once the building is running, the ongoing costs shift from construction to consumption, and electricity becomes the single largest recurring expense by far. A large data center can use as much power as a small city. Industry estimates suggest that cooling alone can account for 30 to 40% of a facility's total energy use, which is why you'll notice data centers increasingly being built in places like Iceland or the Pacific Northwest or northern Scandinavia, where the outside air is naturally cold enough to help chill the servers without running air conditioning around the clock. This is not a coincidence. It is a direct response to a cost structure where every degree of cooling has a dollar sign attached to it. Now here's where the revenue side gets interesting, because a data center doesn't just make money one way. The most common model is co-location, where a company pays rent to place its own servers inside the facility, essentially renting a cage or a rack and paying for power, cooling, and bandwidth on top of that base rent. Then there's the hyperscale model, where a single massive tenant, often a cloud provider like Amazon or Microsoft, leases an entire building or campus for their own exclusive use, signing contracts that can run 10 to 15 years and guarantee revenue long before a single server is even installed. And then there's the wholesale model, somewhere in between, where large blocks of space are leased to mid-sized companies who need more control than co-location offers, but don't need an entire building to themselves. The math on a well-run facility can be genuinely staggering. Once a data center reaches a healthy occupancy rate, something in the range of 80 to 90% of its capacity leased out, the profit margins can climb into the range of 60 to 70%, numbers that would make most traditional real estate investors weep with envy. That's because the marginal cost of adding one more tenant to an already built, already cooled, already secured facility is relatively small compared to the rent that tenant pays. The heavy lifting, the expensive part, was the construction and the infrastructure. Everything after that is closer to pure profit, at least until the building is full and a new one has to be built from scratch. But this business is not without its risks, and the biggest one is the speed of technological change. The server racks installed today will likely be obsolete within 5 to 7 years, replaced by more power-dense, more efficient hardware that changes the cooling and power requirements of the entire facility. A data center built for yesterday's technology can quickly become a liability rather than an asset if it can't be upgraded to handle tomorrow's demands, particularly with the recent explosion in AI computing, which requires far more power density per rack than traditional cloud storage ever did. Owners who don't continuously reinvest in their infrastructure risk watching their prized asset become a stranded one, a building full of expensive real estate that nobody wants to rent because it simply can't support modern workloads. There's also the matter of concentration risk. When your biggest tenant is a single hyperscale cloud provider taking up 60% of your building, you are not really running a diversified business. You are running a single client operation with extra steps. If that tenant decides to build their own facility instead of renewing your lease, which is increasingly common as companies like Google and Meta build out their own massive private data centers, your revenue can disappear almost overnight, and finding a replacement tenant large enough to fill that space is not a quick or simple process. Step back far enough, though, and you start to see the real structural story here, which is that we have built an entire global economy on top of physical buildings that almost nobody sees or thinks about. Every subscription service, every cloud-based business, every AI tool, every online bank, every hospital system storing patient records, they all trace back to a building somewhere with a hum that never stops. The person who owns that building isn't selling software or an app or a clever idea. They're selling something far more fundamental, a guaranteed, climate-controlled, secure place for the modern world's most valuable resource, to live. And because almost nobody wants to build and operate that infrastructure themselves, the people willing to do it occupy a position of quiet, structural power in the economy, one that doesn't depend on going viral or disrupting an industry, just on keeping the lights on, the servers cool, and the rent checks arriving on time. What's remarkable about this business is how invisible its owners choose to remain. There's no data center billionaire doing interviews about their vision for the future. No keynote speeches, no viral product launches. The wealth here is built in silence, in unmarked buildings, behind chain-link fences and unmarked doors, generated by a service so essential that almost nobody stops to ask who's providing it. And maybe that's the real lesson underneath all of this. Some of the most durable fortunes in this economy aren't built by the companies everyone is talking about. They're built by the ones quietly keeping every other company running, one server rack at a time.